So I'm usually of the impression that if I have something that looks like this, the goal is to turn 8 into 2 to the something, right? So what they're doing is they're saying that log base 2, I can change 8 into something with a base 2. So what I need is I need 2 to the 3, right? Because if these two bases are equal to each other, then I should get the power in return. So in exponential form, I do believe that this is 2 to the 3 is equal to 8. Oh, write your answer in 2 to the a equals b. Yeah, 2 to the 3 is equal to 8. Right? 2 to the 3 is equal to 8. And so I guess a is equal to 3 and b is equal to 8. So how do I want to think about this one? So this next one is I have log base 5 of 3125 is equal to 5. So if I could rewrite 3125 as a power of 5, that would be super helpful. And this equation, I think, is telling me that 5 is the answer, right? Because this goes here, and these two things have to be equivalent to each other. So we're basically saying that 5 to the power of 5 is equal to 3,125, which seems reasonable. So C is going to be 5, and D is going to be 3,125. I did, but I don't know why it's not showing up. What is this? Oh my goodness. Log z 1 over z to the 6. So this is like log to some base is like 1 to the 6 over z to the 6. 1 to the 6 is just 1, so this is really log z to the 1 over z to the 6. So I suppose we could probably argue that this is log z to the minus 6. And since these two things are equal, these two bases, that means we can take the power, and the power is going to be our answer. So minus 6. Oh gosh. If ln a equals 2, ln b equals 3, and ln c equals 5, evaluate the following. No! This is so much work. Okay, so for part A, this is ln a minus ln b to the negative 2, c to the negative 2. So we can subtract right away. We know that ln a is equal to 2, so we can get that one right away. We need to, I guess, add these. So ln a is 2, and then we should get ln b to the negative 2. I guess it's technically plus ln c to the negative 2, but I am going to need to put this in brackets. So we get 2 minus ln b to the negative 2 minus ln c to the negative 2. And we're going to bring those powers down. So we're going to get negative 2 ln b, and then I guess a negative 2 ln c. So 3 and 5. So we get 2 plus 2 times 3 plus 2 times 5. So 2 plus 6 plus 10, 2 plus 6 plus 10, so 18. So let's move into part B. So part B, we have the logarithm of b, c negative 2, a negative 4. This is all to the 1/2. And all of that's kind of inside the logarithm, right? So we're going to have to bring that 1/2 down first. And then we can break apart everything else up afterwards. So let's bring that 1/2 down, and then we can then break this apart into a sum of logarithms in the following way. And then I think the same kind of story as part A, we kind of want to bring these negative powers down. So we need like a -2 ln C, and then we're going to need a -4 ln A. And then we'll try to sub in some numbers here. So 2, 3, and 5. So we get -4 times 2, 3, and then 5. Does that come out to be an even number? Can we actually divide that in half? So 1/2, we need 3 take away 10, take away 8. 3 take away 10, take away 8. Isn't that 15? 3 take away 10 is -7. Take 8 more is -15. So it's -15 over 2. And let's take a look at C. So C is ln A to the -4 B to the 4 over ln British Columbia squared. Wow. Look at how terrible that notation is. People chew me out all the time for shit like this. Is that squared inside the logarithm, do you think? Can we bring that 2 down? Or is this ln BC squared? Yeah, I guess you're right. Like, in D, they definitely take this expression to the 4. So this must be inside the logarithm. Okay, I'm cool with that. If you're cool with that, I'm cool with that. That means we should be able to expand the numerator out to be ln of A to the -4 plus ln B to the 4. And then in the denominator, I guess we'll pretend this is inside the logarithm, so we can write this as 2 ln BC. And then we get -4 ln A plus 4 ln B. And then we need 2 times ln B plus ln C. So once we have that, we should be able to now, I guess, do some substitution. So we have 2, 3, 5, 2, 3, 5. Anywhere I see ln A, we can put a 2, so -4 times 2. Anywhere we see a B, we know it's 3. And ln C is 5. So this should be -8 plus 12 over 8 times 2, which is 16. So 12 take 8 is 4, so 4/16 or 1/4. All right, let's take a look at D part. D part, let's bring the 2 down, I guess. So -2 ln C. And then we're going to have to work with these logarithms inside this power. So this is logarithm... Oh, this isn't actually too bad, but I'm still going to use square brackets. So this is a subtraction. We can go logarithm A minus logarithm B cubed, because we have a division. So we have -2. What's ln C? C is 5, right? So this is -2 times 5. Ln A, I think, is 2. And then we're going to get -3 ln B. And ln B is 3. So -10, 2 minus 3 times 3 to the power of 4. 2 take away 9? 2 take away 9 is -7? Who knows 7 to the 4th power? I barely know 7 squared. 2401. So -24,010. That was a pretty big number. Really? Where are they coming from, and why is Twitch not doing anything? Those are the big questions we need to answer. Find the domain of log 5 minus 6x. So we know that 5 minus 6x has to be positive, which means that negative 6x must be bigger than negative 5. We can divide both sides by negative 6, but that means we have to swap the order of the inequality. So I believe that x would have to be less than 5/6, and if we want to write that in interval notation, that could be from minus infinity up to 5/6. We're going to use a round bracket here. We don't want to include that endpoint, otherwise terrible things will happen. Log of 0 is no bueno. And we can go ahead and take a peek at this function as well. So this would be 5 minus 6x. 5 take 6x. So there it is. So it's defined for all of these negative values of x, and then it kind of peaks here at 5/6, right? We have a vertical asymptote at 5/6. All right, chat. If e to the 3x is equal to 27, what does x have to be equal to? Yeah, I agree. Let's take logarithm of both sides. That's going to give us, so the logarithm of the exponential undo each other, and we're left with 3x is equal to the logarithm of 27. So we get that x is equal to the logarithm of 27 over 3. Is that equal to ln 3? Are they equal to each other based on a conversion formula or something?
That's Zeta impressive. Anders is really showing some exponential growth. Keep up the good work. 49 times, huh? That's Zeta impressive. Anders is really showing some exponential growth. Keep up the good work.
Really showing some exponential growth? Oh my gosh. Oh, that's what. Yeah, that's right. Yeah. Okay, I got you. That's why you said ln of 3, right? This is 3 to the 3. You can bring that 3. I got you. You can bring that 3 down and simplify a little bit. Right. So that's how they're connected. Now, I do think that the program will probably accept either answer. The program will probably convert both of these into a decimal number and check and make sure you have your accuracy. But yeah, so either ln of 3 or ln of 27 divided by 3, both of those, I believe, should lead us to the correct answer here for question 6. Now I gotta take, it's been pretty windy and it's supposed to get really cold tonight, so I have to go put like row covers on my tomatoes so they don't freeze overnight. Solve for x in the equation below. It might be helpful to convert the equation into exponential form, write the answer as an integer or reduced fraction. Fine. Let's subtract 4 from both sides so that 2 log 8x is equal to 8 take away 4. And then we should be able to divide by 2. So we want to do 4 divided by 2, which is 2. So this is really asking us 8 to what power would be equal to 2. I have to take the cube root of 8, don't I? Isn't the cube root of 8 2? So the x that I want is 8 to the 1/3. No, that's not right. how does this work again? I'm terrible at converting these kinds of things. Let's just go 8 log 8x is equal to 8 squared. I was going in the reverse direction. So those should undo each other so that x is equal to 8 squared, which is 64. So it's actually 64 that we want. That makes sense. That should be 8 squared, 2 times 2, and that should give us a legitimate answer here. So yeah, I'm okay with 64. That makes sense. Okay, we're on the precipice here, friends. Yeah, x was the inside of the logarithm, so it wanted 8 squared, which is 64. Yeah, I should have been able to recognize that. It's been a very long week. Okay, let's solve for x. This is a subtraction, so we can rewrite this as log x plus 5 over x plus 3. We want all of this to be equal to 1. This is log base 10 in mathematics. So if I want to remove this left-hand side, we need to go 10 to the log of stuff is equal to 10 to the 1. So we're going to get that x plus 5 over x plus 3 is equal to 10. We could multiply both sides by x plus 3, so x plus 5 is equal to 10x plus 3. X plus 5 is 10x plus 30. And then let's just move, can we move? How do I want to do this? Let's swap the side. So 10x plus 30 is equal to x plus 5. And then we can maybe subtract x here, and then we have 5 take away 30, which would be negative 25. So it feels a little bit awkward, but let's take x to be negative 25 over 9 and see if that would make sense. Negative 25 over 9. I think both of these logarithms would exist, right? Because that's always the one concern, is that maybe when we do these additions, they may not. So if I take, let's see, if I take negative 25 on 9 and I add 5 to that, what do I get? I get a positive number, so that should be fine. And if we add 3 to it, still a positive number. So I think we're going to be okay here. We can take negative 25 on 9, and I think that should work. But yeah, we do want to double check those values inside the logarithm. So take your x value, double check those numbers in the logarithm, and make sure that they don't end up being a negative value. Otherwise, we're in a little bit of a world of hurt. Okay, I think this might be the last question of the evening. You are more than welcome, Punching. Last question of the night. A culture of bacteria grows according to the continuous growth model. Okay. Where B is the number of bacteria, T is in hours. Find F at 0. That's just subbing 0 in, so that should be 500. It's going to be our initial population. Right, we get 500 times 1, effectively. To the nearest whole number, find the number of bacteria after 5 hours. So that's going to be evaluating F at 5, which is 500 e to the 0.0735. Yeah, I can't imagine this is going to come out to be something nice. So let's go 500. This is going to be probably terrible. Do we have an exponential thing? Yeah, it's over here. So e to the 0.073 times 5. So about 700 to the nearest whole number. So 720. To the nearest tenth of an hour, determine how long it will take the population to grow to 1100. So we need the output to be 1100. And we're going to solve for t. So the first thing that we want to do is do this division of 1100 divided by 500. So that'll give us 11 over 5. I don't know why I needed to do that in my calculator. And then we need to take the natural logarithm of both sides, and that's going to allow us to get rid of that e on the far side. So that's going to bring down the power. And then if I want to calculate t, I can take ln 11/5, and I can divide by this decimal number of 0.73. So I'm just going to type all of that into the calculator. So we'll go fraction, we'll go logarithm of a fraction. That's 11/5. And then we need to divide by too many dots, 0.73. So we get 10.8 to the nearest tenth of an hour. Yeah, there we go. So 10.8 is what we're looking for there. Okay.